For that, we will revise the previous one. Okay. So one question I'm just giving, right? And you need to solve that one. Okay. So there,
Okay, sir.
the question is the velocity v of a particle.
Yes, sir.
The velocity
Hmm.
v of a particle. The velocity v of a particle
Hmm.
depends upon the time.
T.
Yes, depends upon the time t. According to the equation, according to the equation, v equal to a plus bt plus cy d plus t. Okay,
Okay, sir.
write the dimensions of a, b, c, and d.
Okay, sir.
Write the dimension of a, b, c, and d. Okay,
Okay, sir.
the question is the velocity v of a particle depends upon the time t. According to the equation, v equal to a plus bt plus c by d plus t. Find the
Yes, sir.
dimension of a, b, c, and d. Okay.
Okay, sir.
Uh, so from the principle of homogeneity, from the I'm giving a solution regarding it.
Yes, sir.
From the principle of homogeneity, we have a equal to dimension of b, right?
Yes, sir.
Because v equal to a plus bt plus c by d plus t. So whatever the dimension of v, that dimension will be the same of a, right? A will be having
Yes,
same
sir.
dimension as of b. So we say that v is the what? Okay, v is the velocity. V is the velocity. So that
Velocity.
is lt minus 1. So a having a dimension lt minus 1. It's very easy, right?
Yes, sir.
Now we are bothering about the dimension of bt. So the dimension of bt will be same as the dimension of b, right? So here we need to
Yes,
find
sir.
dimension of b only. So t will go on the other side and it becomes v by, it becomes v by,
T.
right, t, v by t,
T.
and that is what v
T.
power t power minus
Minus
1,
2.
right? So
Minus
it
2,
is
sir.
what lt minus 2, lt
Hmm.
minus 2.
2.
Yeah, this is the dimension of b. It is the dimension of b, right?
Hmm.
So b having dimension lt minus 2. So it is looking like acceleration, right?
Yes, sir.
Hmm. Next, we need to find the dimension of, right, C D, right,
Yes,
C
sir.
D, no? So
Yes, sir.
C, here you are seeing that the dimension of T will be T is capital T, and D is attached with T, means both should be the same thing, then they will add. So D will be also time, right?
Yes, sir.
Because we are knowing that the same quantity will be added with the same type, right?
Yes, sir.
So here T, C by D plus T. So in the denominator we have D and T is time. So we say that D will be the same thing as of T, right? The T is the time, so D will be also time, right?
Yes, sir.
Absolutely. So we have the dimension of D, right, will be dimension of T, and that is T. Dimension of T. Are you
T.
getting?
Yes, sir.
Yeah. Uh, Now we are going to bothering about C by D. C. We are going to calculate the dimension of C. So how we can get the dimension of C? So here C by D plus T. D plus T.
T.
So C by D plus T, that is all added with BT. So and V equal to A plus BT plus C by D plus T. So all should be the velocity. All should be the velocity. That's why
Velocity.
they are having plus operator. Okay.
Yes, sir.
So we have C by D plus T. The whole thing is like a velocity V. Whole thing like a velocity V.
V.
Here. Here whole thing C
Yes, sir.
by, you are seeing that no, C by D plus T, that is, this will be the same thing, this will be the same thing, and this will be the same, right?
Yes, sir.
So in the same way we can say that C by D plus T will be the dimension of V, and we are knowing the dimension of V, that is what, V LT minus 1,
L T
and
plus.
this is D
Yes, sir.
plus T will go here, and they will be multiplied to each other. So this will be the dimension of C. So this is C here, LT minus 1, and here D plus T. So D plus T, what it will give the dimension?
T
What it will
power
give the
2.
dimension?
Only T.
Only T, yeah. Because D and T both are same. Both are time.
Yes,
So
sir.
they will give us time, right? So it is what?
Yes, sir.
The one once we will calculate, this will be what? L only. This will be only L.
L.
Right? So dimension
Yes,
of
sir.
C will be only length. Will be length.
L.
Right? So
Yes,
in this
sir.
question we have dimension of A, and that dimension of A is velocity, that is LT minus 1. We have
Yes,
dimension
sir.
of B, that is LT minus 2, LT minus 2, and we have dimension of D, and that dimension of, we have dimension of D, and that dimension of D will be, dimension of D will be T. Dimension of D will be T.
T.
Okay?
Okay, sir.
Have you noted down?
Yes, sir.
Okay, so A is the velocity, like a velocity, we say that A will be velocity. Not exactly, but it can be, okay? It may be. And B
What,
will
sir?
be the dimension of A. Dimension of A.
Yes, sir. Yes, sir.
So it may be,
It
well,
it's look
it
like
may be
the
velocity.
dimension of velocity, but it
Uh,
is not compulsory that it is the velocity. It is the dimension
yes,
of
yes,
velocity.
right.
Okay, sir.
In the same way, B, C, and D also. Okay.
Okay, sir.
Hmm. So this was the question. Now I'm giving you another one, right? What is principle of homogeneity?
Principle of homogeneity means uh, dimension of if two
LHS
equations
will
are
be equal
equal
to,
equal to RHS.
yeah, yeah, good. Now we have a question. If the centripetal force, if the centripetal force, if the centripetal force
Yes, sir.
is of the is of the form that is m power a v power b and r to the power c, r to the power c,
C.
find find the
Yes,
value of
sir.
a, b and c. Find the value of a, b and c. Okay, a
Okay, sir.
m to the power a, b to the power b, r to the power c. Find the value of a, b and c.
Yes, sir.
So what is the value of a, b, c? Here we have that is force equal to centripetal force, right?
Yes, sir.
We have
Centripetal.
force equal to mass, है ना? Velocity, that is we say that mass mass power a into velocity v, right?
Yes, sir.
We have velocity that is b, थोड़ा सा into we have length c, we have length
Yeah. C.
uh, that is power
Radius.
c. So we say that simply, okay, force is in this form m to the power a, b to the power b and r to the power c, r to the power c. So
C.
force having dimension m l t to the power minus 2, t to the power minus 2. Okay.
Yes, sir. Yes, sir.
Hmm. Here m, here we have m, only mass power a, right? Power.
Hmm.
A, we have velocity LT
Uh,
minus 1,
yes, sir. T
that is
minus 1.
B, yeah,
B. Yes,
and
sir.
this is R. R is the length, so it having dimension L, and that is will
Yes,
be
sir. A
same.
to the power 2.
Now we need to equate all those things. Okay,
Hmm. Okay, sir.
uh, equating the exponents of similar quantities, equating the exponent of
Hmm.
similar quantities of
Similar quantity.
similar, yeah,
Yes,
quantities.
sir.
We will get A equal to
A to the power
1,
1.
B plus C equal to 1.
B plus C.
Hmm.
Okay, sir. Yes, sir.
Here L per power B or L per power C, both having same base, so they will add together. And the last one minus B equal to, that is last one, B equal to, minus B equal to minus 2. Okay.
Yes, sir.
So we have A equal to 1, we have B equal to 2, we have C equal to minus 1. So we have F equal to M, F equal to M V square, that is by R. This was the value of ABC, and once we put the value of ABC in the given form of centripetal force, right?
Yes, sir.
So we have this formula: force equal to centripetal force equal to mva square by r. Have this formula,
Right.
right? mva square
Yes, sir.
by r. So in this way we say that this is force equal to mv square by r. It's like a centripetal force formula. Okay, it's like a
Yes, sir.
centripetal force formula. Okay, right?
Yes, sir.
So this was this equation. Now we are going to learn the new concept, right?
Okay, sir.
Hmm. Are you writing all those things?
Yes, sir.
Hmm. Hmm. Okay, so I have given that assignment to you. Have you finished?
Which assignment?
First day?
First day? No, sir.
Hmm. Okay. Okay, I will give. Hmm. So today we learn. Okay,
Okay, sir.
to establish the relation among various physical quantity. Okay.
Hmm.
Various physical quantities. Clear?
To establish the relation among various physical
Various
quantities.
physical quantities. Okay?
Okay, sir. Okay, sir.
So here, if we are knowing the factors on which a given physical quantity may depend, we need to know the factors of a given physical quantity. Okay?
Okay, sir.
Factors, parameter on a given physical quantity depend. Then we can find the formula relating the quantities with those factors. We can get a new formula based on that factor. Okay?
Okay, sir.
We can find, we can find, we can find the relation. You can find the relation. You can find the relation among physical quantities. We can find the relation among physical
Physical
quantities.
quantities.
Yeah, physical quantities. How? Okay, so we have one example regarding it. Example number one. That is what? Suppose we have uh, there is a one Bob. There is a one Bob.
Bob. Hmm.
The fixed support. This is a support, right? This is a
Support.
support. And this is string. This is
Sting.
string. Are you understanding? And
Yes,
this
sir.
is
Sting.
Bob. Uh, this
Bob.
is Bob. This is Bob. So this string is inextensible and very lightweight, massless. We can say that this length L, string having length L, and it is massless, inextensible. Okay, it will not expand, right? Its length will be fixed. Okay,
Yes, sir.
whatever the condition will be, it will not expand like a rubber or anything.
Okay,
Hmm?
sir.
So that we
Okay,
can
sir.
calculate the so it is inextensible and massless. There is no mass of this string, and this bob having mass
Yes,
m.
sir.
This bob having mass m.
M.
Okay,
Okay, sir.
yeah, mass. Okay, this string
Okay, sir.
having one more thing. The condition is, this string L of length. This string having mass per unit length, that is mu. Mass per unit length, right? Mass per unit length. So mass unit length of string of the string, mass of length of a string will be mu. It is what? Mu.
Mu.
It is
Mu.
mu. Are you understanding?
Yes, sir.
Mu. Hmm. So then we need to find the formula for frequency. Okay. We need to find, derive the formula for frequency. Formula for
For frequency.
frequency, yeah. Formula for frequency. How we can find that? Suppose the frequency f depends on the tension. Tension means what? One kind of force, right? Raised to the
Yes, sir.
power a, length raised to the power b, and mass per unit length raised to the power of c. So we say that this frequency f, that frequency is directly proportional to the force, right? Force,
Yes, sir.
okay, force, that is tension, right? So this
Okay.
frequency directly proportional to the force. This is also directly proportional to the length, and this is also directly proportional to mass per unit length, right?
Okay, sir.
The frequency, frequency means what? The string will come to its initial
Mean
position, right?
position.
After some
Yes, sir.
certain kind of, if any force will acting on the bob, and bob will go to the extreme, and once it will return back to its return back to its original position after 1 second. After
1 second.
1 second, in 1 second, the total number of oscillation or
Okay.
repetition, right? Uh,
Okay, sir.
Total number of oscillation or repetition in 1 second. That is called frequency. Okay.
Okay, sir.
Hmm. So this frequency is related to the tension in the string. Means how much it is tightly hanging from the support. Okay.
Okay, sir.
That is called tension, and it depends directly to the length, and it depends upon mass per unit length. What we need to do, we need to put some power, that is suppose A, B, and
B and
here
C.
C. Here C. We are not
Okay,
knowing
sir.
what is the value of A, B, and C. We just put the value of A, B, and C, and it is totally unknown. Okay. So these are
Okay,
variables.
sir.
We put A power, okay, on
Okay, sir.
the force, we put the power B on length, and we put the power C, that is
On.
on mass per unit length. Okay.
Yes, sir.
So when in the physics, whenever this proportionality sign is there, this proportionality sign, right? So whenever this
Yes, sir.
proportionality sign will be there, what we have to do, we just remove this proportionality, and we put a constant value k. Okay.
Yes, sir.
Ah. So this is F, right, and this is A, this is what L, and this is power B, this is power B, and this is what mu, this is power C. This is power
C.
C. Okay, where K is the dimensionless constant, right? Here,
Okay.
here K is a dimensionless
Dimensionless
quantity. Because it is a numeric value. It is a numeric value. We
value.
don't know what is this numeric value. So we are not going to bother about. So we have a
Okay, sir.
frequency, and that frequency having this frequency f, and that is having f, okay, a, and this is what length l, b, and this is what mu, that is c. Okay. So this is f
Okay, sir.
frequency. Now we need to calculate the frequency having dimension m to the power 0, right?
Okay, sir.
L to the power 0 and t to the power minus 1. We are knowing that frequency. Okay.
Okay, sir.
Are you observing what I am writing on the screen?
Yes, sir. Frequency's dimension is t to the power minus 1.
Yeah.
Like
We
me.
have in the dimension of force, what is m l, t to the
Yes,
power
sir.
minus
Minus
2
2.
power a. This is
Yes, sir.
L to the power B, and one more thing, that is mass per unit length. So this is M L per power minus 1. In the next slide I will
Okay,
do.
sir.
This is what?
M L to the power
First
minus 1 to the power
M
C.
per power 0, L per power 0, T per power minus 1, right? Now M L T per power minus 2. This is having
Yes,
A
sir.
dimension L. This is having
Yes, sir.
power
B.
B,
L to the power B, huh?
and this having power not T, per unit length. So we
M
have
L to the
mass
power minus
M
1.
per unit length L minus 1, L minus
1. 1.
L minus 1,
1
and
to
that
the
is
power
C.
C.
That is, hmm.
C.
Now we are going to compare, right? By calculating first L to the power 0, T to the power minus 1, and that is M, right? M to the
Yes,
power
sir.
A. M to the power A here
A.
plus C. Here L to the power A plus B plus L to the, sorry,
C.
minus what?
Uh,
Yeah, minus
A.
C.
C.
Minus C,
Minus C.
right?
Yes. Yes, sir.
Then we have T to the power minus 2A. Minus 2A.
2A.
Okay.
Okay, sir.
So by according to principle of homogeneity,
Homogeneity.
dimensions should be same. Dimension should be
Yes, sir.
same. The
Same.
dimensions on both sides should be same. So we say that by principle of
A
homogeneity
to the
or
power A plus
for
C equals
dimensional
0.
balance,
Yes, sir.
yeah, for for dimensional balance, for dimensional balance, the dimensions the dimensions on
Yes,
both
sir.
side on
Both sides.
both uh, dimensions on both side should be same, right?
Yes,
Both
sir.
side,
Should be same.
yeah, should be same. So now calculate and tell me what is that. First equation is A plus C equal to
C.
0.
0.
Yeah.
A plus B minus C equal to 0.
Hmm.
Minus 2A equal to minus 1. So A equal to 1 by 2.
Yeah. We have
तो इसको पुट
A
करेंगे
plus
फर्स्ट इक्वेशन में.
V plus A plus C equal to 0, right? We have A
Yes, sir.
plus B minus C,
C
that is
equal to
equal to
minus
0, and
1
we
by
have
2.
minus 2. We have minus 2, right? A, that is equal to minus 1. So after solving this equation, finally we have A equal to what? 1 by 2. We have C
C
equal
equal
to
B
A
minus 1 by 2. B equal to 0.
equal to minus 1. B equal to minus 1.
Minus 1.
Okay?
Oh, okay, sir.
B
Yes,
equal
sir.
to minus 1.
Yes, sir.
Are you understanding?
Yes, sir.
So what we do after putting all those values, right? After putting
Yes, sir.
all those
Those values.
values here,
Hmm.
uh, we will get what we will do. We are putting these values, okay? So we
Okay,
have
sir.
frequency, that is f, and this frequency, the k is the dimension, and we have force F, and on that force we have power, that is A. Here A having value 1 by 2, and L having value, that is minus that is minus 1, that is minus 1,
Minus
and
1.
we have a mass per unit length, that is mu, and that having dimension what? Minus 1 by 2, minus 1 by 2.
2.
Okay,
Yes, sir.
so we have frequency. Finally we have frequency when we combine that one, that is k by l, k by l, and then f and mu having same 1 by 2, but it is minus 1 by 2. So both will come down, and in this way, like f by mu, f by mu. Okay,
Okay, sir.
so this will give us, okay, so lot of experiment has performed, and based on that experiment we have value of k, and that value of k is 2 pi root under L by G, 2 pi root under L by G. So that is, here we have experiment, and that we can say that 1 by 2, that is what, 1 by 2, we can put that, no issues, 1 by 2, and here L, and we have, this is f by mu. Okay,
Okay, sir.
we can put the value of k by according to your desire, but here lot of experiment is done, and based on that experiment its value of k is 1 by 2. So 1 by 2 root under f by mu, this is the
Mu.
final result. Okay,
Okay, sir.
so based upon the parameters, here we have, that parameter is what, mass. Here we have, okay, mass, as I have told already. Okay, we can find the, here we have length, right, mass per unit length and mass, all things are there, right, all those
Yes, sir.
things are there, and mass, length, and mass per unit length. So based on this parameter, force, length, and mass per unit length, we can get the exact value of that. Suppose we are not knowing what is the power of that, so we can put the powers in variable form, a, b, c, like that, and with the help of principle of homogeneity we can get the value of values of variables, and after getting all the values of variable, we are putting those value over the given parameters, and finally we get the desired. Okay,
Okay, sir.
are you understanding?
Yes, sir.
Okay, so shall you, I will give you another question, can you do it?
Okay, sir.
Yeah, so do that, I'm giving you another question.
The time in which you are talking about is the
Huh.
questions now. I have done it.
You don't know? Okay, I will ask later on.
Okay, sir.
Okay. Hmm.
Okay, sir.
So you just noted down this question. I am writing over here. Okay.
Okay, sir.
When a solid sphere, when a solid sphere, you are seeing this solid sphere like that. This is
Yes, sir.
a solid sphere. In this solid sphere, you have that radius r, right? You have radius
Yes, sir.
r.
R.
Yeah. This solid sphere, when this solid sphere, okay, you are seeing that the radius obviously it will be having r, will be having radius r. When a solid sphere moves through a liquid, okay, moves
Through a liquid,
through,
yes, sir.
yeah, a liquid. Okay, suppose this liquid can be water. So a solid sphere, suppose deuce ball, and that deuce ball is floating over the water. Okay.
Okay, sir.
So in the same way you can understand. And the liquid opposes the motion with a force F. The the liquid does not want to, liquid does not want to let move the object of that sphere on the surface of. So liquid applies a force.
Okay,
liquid
sir.
opposes the motion. Okay, the liquid opposes means what?
Repel.
Huh? Opposition opposes the motion means what?
Opposes
It
the
will
motion
apply
means.
a force in opposite direction, right? Opposes the motion.
Yes, sir.
Opposes the motion
Motion.
with a force with a force
Okay.
F. Okay,
Yes, sir. Okay, sir.
the magnitude of F, the magnitude of F depends on the depends
On the
depends on the coefficient of viscosity. Coefficient. Do you know what is meaning of coefficient?
वेरिएबल से पहले जो आता है नंबर, उसी को
Yeah,
कोफिशिएंट बोलते
the coefficient of viscosity eta of the liquid. Eta of the
हैं. विस्कोसिटी क्या है सर?
viscosity means, suppose if I am moving on the surface of earth, okay, if I
यस
am
सर.
moving on the surface of earth and I am just putting my leg in the forward direction, earth will apply a force in backward direction on my leg. Okay,
ओके सर.
earth will not in the forward direction. Earth will apply opposite direction, opposite force on my leg, right?
ओके सर.
So in the
विस्कोसिटी
way, if any
के
object,
बाद क्या
in the
लिखे?
same way, if any object, yeah,
विस्कोसिटी के बाद क्या लिखे?
viscosity of the liquid, viscosity eta.
ईटा.
Hmm. This one no.
यस
Hmm?
सर. यस सर.
This is called
ईट.
eta.
यस.
Some people are understanding like that, eta or like that.
ईट.
Okay.
यस सर. यस सर.
Viscosity eta. If to move on the surface of liquid, liquid will not let to move the water in the friction. Liquid will apply a liquid will oppose the motion of that body, and this is called one kind of friction opposes one kind of friction. Okay, exerted by the layer of the liquid on the surface of object that is flowing on the floating over the surface of liquid. Okay.
ओके सर.
Liquid, viscosity means what? It is a kind of friction, but it is friction between liquid layer and a solid object, or in liquid layer or liquid layer. Okay,
ओके सर.
normally friction means what? Solid object and solid object, that solid object and solid object are rubbing to each other, then there is a force,
यस.
that force is called friction. Okay,
यस सर.
are you understanding?
यस सर.
So in the say, if any liquid applies the force on any solid object, that is called, that force, opposing force is called viscosity. Okay, I will
ओके सर.
teach that one in the friction chapter, in properties of matter in the liquid state, right?
ओके सर.
Fluids, there is a fluid mechanism on that. Okay,
ओके सर.
So next is here we have the radius r of the sphere. The radius r, the radius r of the sphere, okay,
Okay, sir.
and speed v of a sphere, and speed v of the sphere. Have you completed the question?
Yes, sir.
Hmm. So
So the
here the
radius
force
of
is
the sphere wi- co- depends on the coefficient of viscosity eta of the liquid.
yeah,
और उसके बाद
yeah, eta of the liquid, and then radius r of the sphere
अच्छा अच्छा
and speed v of the sphere. That is on the screen.
yes sir I'm writing
Solve it.
done
Finish.
yes sir
What is the answer?
sir I'm not solving the question the
Uh,
question I have
Solve
written
it.
the question
I'm giving you hint. Force is that opposing force is equal to k times of eta, right? To the
yes sir
power a. Eta to the power a. Radius r to the power b, and velocity to the power c. Here you are seeing that eta, that is what? Eta is viscosity, coefficient of viscosity. Okay.
okay sir
And r is the radius, v is the velocity.
okay sir
Right now you just learn the dimension, and later on I will tell about the dimension of viscosity. Okay.
okay sir
So we have force having dimension m l t पे power minus 2. Okay.
two yes sir
And then viscosity having dimension m l पे power minus 1 t पे power minus 1. Okay. This
okay
is
sir
a, this is a,
a
this is a, and
a
l to the power, that is b,
b
that is b, and
yes sir
then we
और
have
l
that
t
is
की power minus 1
l
to
to
the
the power
power
t, that is c, that is c.
c
So when you have these values, a to the m to the power a, l to the power minus a, b plus c, right, and
yes
t to
sir
the power minus a minus c. Okay.
okay sir
Now we need
okay
to
sir
compare this and tell me the values of variables.
minus a minus two
Finished.
minus. Wait just a minute, sir. A equal to 1,
A equal
B
to
equal to 1, 1,
hmm,
B equal to 1, C equal to 1.
A equal to 1, B equal to 1, C equal to 1, right? So all having
Yes,
C.
sir.
So put all those things on the formula. Put all those things on the formula.
Yes, sir.
What you will get?
Wait, minus 1. Sir, where I have to keep the value?
There is here A eta
Oh,
F
okay,
equal
sir.
to
K equal to e to the power minus 1, R1 or V1.
hmm, hmm. Finish.
Yes, sir.
So you will get like that.
Yes, sir.
Eta R into V. So force equal to this is force equal to eta R into V. Okay.
Okay, sir.
So when I will teach now this value in fluid mechanics, that is what 6 pi eta R into V. Value is like 6 pi eta R into V. That one I'll tell you later. Okay.
Okay, sir.
So this much only, right?
Yeah, okay, sir.
And I will send some questions through the WhatsApp.
Okay,
Okay.
sir. Okay, sir.
Any doubt?
No, sir.
What you need to do in this question? You need to collect all the parameters, put variables over
Yes,
there,
sir.
and you just equate it,
Yes.
LHS and RHS powers.
RHS. Yes, sir.
Yeah. Tell me what you need to do.
We have to equate the LHS and RHS and put the values of the
First you need to put all
uh,
the factors. Put all the
factors.
factors
Yes, sir.
together and put variables as a power over the
Yes, sir.
factors, and then comparing equation and
Yes,
get
sir.
all the values of variables, and then after on the last you will put all the powers over the factors,
Over the
physical
factors.
factors.
Yes, sir.
Tell me once again.
We have to equate the LHS and RHS and put all the
Ah,
factors over the parameters.
hmm. First
After
you need to do what I'm telling you. You need to, okay,
correct all the
first,
parameters, all the factors.
ah, yeah, step one, you need to put all the parameters together. Put
Yes,
all
sir.
the parameter of
Parameters together.
factors. Put all
Yes, sir.
the factors together.
Okay, sir.
uh, and then second step, put powers. Okay, put
Okay, sir.
A,
Power.
B, C, D, and like that. Okay, as powers over
Yes, sir.
variables, over
Variable.
no, not variable, over factors, over
Factors.
factors or parameter. I'm writing over that. Are you
Yes, sir.
understanding?
Yes,
And
sir.
on the last you need to equate. On the last you need to equate. Third step. Step third. Anna, you need
Yes, sir.
to equate. After equating, you will getting the variable ABC and putting all those things over the factors. Okay.
Yes, sir.
Hmm. So now it's over the class, right? Can you tell me? Can you show me your notes?
Today's copy, or you have given the questions, that one.
Uh, yeah,
Both.
both.
Okay.
Wait, I'm coming. Be seated there. I'm coming. Right. Outside seated. Good, good. 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 Okay, so next day, very good.
Yes,
Okay,
sir.
next day I'll tell you the schedule for that. Okay,
Okay, sir.
fine.
Thank you, sir.